So I figured I'd make a video on how to do dome style boost control for you guys. I'll show you how to do it in the HP and Dominator software, and I'll show you how to do it in the Terminator software. It's basically the same. The only real difference is the pin maps are a little different. And you want to make sure you know where you're going to pin everything and how you want to trigger and blah, 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 blah. You want to know all that before you start wiring and set everything up. Here's a pin map for HP and Dominator, and you can open up your pin map right up here, and this will pop up, and it'll show you all these letters and numbers, and they all mean something. F is for frequency, 5 is 5 volt, 2 is 20 volt, T is what is it? Thermistor. I don't even know if I'm saying that right. But temperature style. And then H is 12 volts and G is ground. So you can see what inputs can handle those things, and then you'll have to wire it accordingly. And then same for your outputs. On HP and Dominator, they can do 12 volts on input 1 and 2. So they can do 12 volt trigger and positive PWM, pulse width modulation, and output 3 and 4 is the opposite. They can only do ground and negative pulse width modulation. So you'll have to take that in consideration when you're wiring everything. If you only have an HP and you want to do boost and trans brake / bump, you'll have to take this into consideration, because normally we'll do the boost solenoids on the negative side. So we'll put 12 volts to one side of the boost solenoid, and the other side will come to the Holley, and we'll do a negative PWM on it. Once you do that, then you only have positive triggering on the output. And normally we all use the NOS solid state relay to do trans brake and bump, but it's negative triggered. So you can't run it on the first and second output. And if you need to swap your boost solenoids to positive or negative triggered, what you got to do is you go to the boost ICF, go down here on the left hand side to inputs and outputs, and right here it'll tell you what type of output your boost solenoids are, and you could swap them to PWM positive or negative. So what I did on mine is I put my vent on a positive PWM, and I put my trans brake on a negative PWM. The boost solenoids can take positive or negative triggered, it doesn't matter, just the other wire has to be the opposite on the solenoid. It's fine. We just normally will do negative because they seem to work faster from what I understand. I've never sit there and messed with it both ways and figured it out, but I've always heard that's faster to negative trigger them. So I'll negative trigger the fill and positive trigger the vent. But when you go to Terminator pin map, it's a little different. On the inputs, they're all the same. They can all do frequency, 5 volts, 12 volts, and ground. You go to the outputs. This is just some random file to show you guys. They're all the same. There's no more positives on the first and second output. They're all ground triggers and negative PWM triggers. So this, you can do everything on a ground and you don't have to worry about it. So you can do the NOS solid state relay and both your boost solenoids, and you can do them all negative triggered and you're fine. So that's the main difference really between setting up the two. As far as setting it up in the boost ICF and everything, that's all the same. Which I'll show you guys. You go up here to toolbox, add individual config. Oh, sorry. This is what it'll pop up when you hit the add individual config, and you go to boost, default boost. Oh, it's just telling me it won't be compatible with a 1-bar sensor. Okay. You go up here to the little boost ICF, picture the turbo, and here's all your boost settings. But before we get to this point, I want to show you guys how to plumb it. Right here is a really good picture showing you guys how to plumb the sucker. You got your 2-3 port Mac valves or whatever. We always use Mac valves. You plug the number 3 port on both of them, and number 1 port on the fill will be your pressure source. If that's CO2, onboard air, or the compressor discharge air off the turbo. So if you're using just turbo pressure for your boost control, right here on this green line that goes to the bottom of the wastegate, you'll tee off here and go to the pressure source. But that's only if you're using just the turbo for boost control and you're not using CO2 or onboard air. But you can see the way they got these set up. Most wastegates have multiple ports on top, so this is really easy. You just have your dome sensor tied into the top, a T in between these two, and it ties into the top, and the number 2 port on the vent just left open. So when you set it up at whatever dome pressure you want in your software, these will just be sitting here and constantly trying to regulate whatever pressure you put in the software here. If you say you want 30 pounds of dome, the sensor will tell it, you know, I'm not there yet, so it'll keep adding, and once it sees 30, then it'll start going back and forth between the fill and the vent, keeping it at 30. And you'll have to mess with your PID loops and stuff, and that might be over some of your guys' heads. The standard PID loop is normally pretty good right here in the dome control setup. It's normally pretty good, but if you want to get it perfect, you'll have to sit there and really mess with it in the garage. But I'm not going to show you guys how to do that. I can show you another time how to do that, but I'm just showing you guys how to set this sucker up, wire it, and plumb it. But yeah, I think that's it as far as plumbing goes. It's pretty straightforward once you look at this diagram on how to do it. This dome sensor, it'll be a 3-wire plug, and it'll need 5-volt source, it'll need sensor ground, and then it'll have a signal wire. The signal wire will go to the ECU on the input harness. You can put it wherever you want, as long as it can handle 5 volts, you know. And I'm pretty sure both of them will handle 5 volts. Yeah, so you can put it on any input. And the easiest way we found to do this is the power tap. If you have a newer harness, I believe they all have a power tap, which is just like a plug with 4 wires in it that's in the harness with nothing on the other end of it. And you can tap into that, and it will say what pin's what on the plug. But it's got chassis ground, sensor 5 volts, and then engine running 12 volts. So basically when the fuel pump's running, it'll be putting out 12 volts here. But anyways, you'll need the 5-volt sensor, or sensor 5 volts, and sensor ground to go to your dome sensor. And that's just, it just keeps it really simple, really easy. You don't want to be hacking stuff up. But if you have a harness that doesn't have a power tap on it, you can cut the fuel sensor wiring. You can cut that up and use that and just steal the sensor ground and sensor 5-volt from it. The black wire will be sensor ground, and I believe it's an orange wire, is sensor 5-volt. The purple wire will be the signal wire, so don't touch it. But if you have a power tap, this is the easiest way to do it. Don't put your ground to chassis ground. It needs to be a sensor ground to get a good clean signal. Let's see what else here. So once you got the boost ICF all set up in the Terminator, you don't have any other choices. So I mean, it's already set up the way it needs to. But on HP and Dominator, you can click dual port wastegate dome control. Okay. And you have all these you can pick from. And you can also do map and dome on this. This is how we have it set up, the dual Holley and everything. On the Terminator, you can't do it a bunch of different ways. You have to do dual port dome. But on the HP and Dominator, you can actually change all this. And you could do single, dual port. You can do it as duty cycle and dome and map and blah blah blah. But that's not what this video is about. But and up here is where you'll tell it if you're going to be using a compressor that's from your turbo. If you're just running boost pressure for your boost control, then you'll just click compressor. If you're using CO2 or onboard air, you'll do fixed, and this number right here will be whatever your regulator set to on your CO2 bottle or your onboard air. And then over here you have all your safeties. Normally I start out kind of low, depending on what it is, what the combination is, what the end goal is. And I'll go revert to wastegate, at like 20 pounds or something, and then do 22 for 0.1 and cut ignition. That's pretty normal for me starting out on something, depending on what it is. Like I said, this is where you set up, if it's a compressor, which is just from the turbo, or fixed, which is CO2 or onboard air. And then right here is where you pick your dome sensor input. Well, there's nothing there because we haven't set it up yet. So you got to go back over here to Toolbox, add individual config, IO, base config. Then go over here to the inputs and outputs ICF, make a new one, dome, enabled, 5-volt. Okay, configure. You want to make it a Holley 100 psi. Alright, cool. You go back over here to your boost ICF, dome control setup, and it already did it. And it's as easy as that. Then you can go over here and set up your scramble. And you can go over here to your, most of you guys are going to be boost versus time. But some of you guys on the street that are roll racing or just want to play around, you might do gear, RPM, or speed. On the dyno, we'll do RPM. But if you're racing at the track, you're going to be on boost versus time. And then you just make your ramp here. I always do them. I always set this up differently. And just something, you know. Then you got yourself a boost ramp. At the very end, whatever time you're running, if you're doing an eighth, quarter mile, whatever, the second to last one, it needs to be a little bit longer than where you need it. And then right after that, just make it a second longer, whatever, and go to 0. That way that it'll shut everything off after that time. But also when you have the TPS modulation enabled, it won't be doing anything under 50% anyways. But that's just how we always set it up. Let's see here. This is the Terminator. It's the setup the same. I mean, it's almost identical. So I don't really need to show you guys anything differently on that. Oh, I'll show you guys how to pin map everything. Then up here you got your T-brake launch, which will be also your rev limiter 1. Your rev limiter 1 and your T-brake launch will all be the same on the same input. And then your scramble will be whatever, and then your dome will be whatever. Just like I said, just make sure you put them in the right place where you're going to wire them. And your scramble, if you're doing bump on the car, your bump and your scramble can be on the same button, so you're not wasting an input. And now we got our inputs set up. We'll go to outputs. Then you just have the boost fill and the boost vent. They're both on negative. Like I said, you could change them to positive PWM if you need to. On HP and Dominator. On Terminator, they have to be negative because it'll only do negative outputs. But I think that's about it on setting up boost dome control. And a lot of people, they might get confused and think that your dome pressure is boost numbers. It's definitely not. It is just the measurement of the air on top of the gate. So it's not going to be 100% accurate. It's going to take some trial and error. Every car is different. It's not a perfect science. You're just going to start slow and slowly work your way up and see where it's at. You know, some cars, 10 pounds of dome will make 10 pounds of boost. Some cars it'll make 20. Some cars it'll make 5. I mean, it just all depends on the combination, and it's just something to play with. Don't go crazy in the beginning when doing a dome control until you figure out what amount of dome makes what amount of boost. But I think that's it for you guys. If you have any questions, just message me or get with me on Facebook or whatever, comment, whatever, and I'll do my best to help you guys out.